Hi guys, our last video was about buying your first drill, so this one is going to deal with the tooling that you can put into it. I'll do this again on the basis that you have no familiarity with drill bits or cutting tooling of any description. Now in that light, all drilling and fasting is done clockwise, in a clockwise direction. Now this is by no means an exhaustive list of all tooling. I'll try and cover the basics, and then I'll be referring to other bits and pieces which, whilst not relevant to the beginner, will give you some awareness for the future, or at least let you know that there are other options out there. I prepared a chart with the areas I'm going to cover today, and we'll use this to navigate the various options. So the chart is up on the screen there, and basically our tooling that we're looking at today will come in three sections. One is hole making, two is fasting, and obviously unfasting that will form part of that, and number three then is other rotary tooling. So if we go over to the left hand side and look at our hole making section, this involves drill bits, and these can also be called twist drills or bits. Generally the common convention is that the machine itself is called the drill, and the things or the tooling that goes into it are called the drill bits. Now I've divided these into three categories. Number one, metals; number two, masonry; and number three, wood and soft materials. Now, a common theme with all of those three cutting or drilling operations is that they can all start out with a solid drill bit, which obviously drills the hole. But then when we come to larger diameter holing requirements, they all go up to a sort of a second type of cutter, which in the case of wood would be regarded as a hole saw. With metal, they're called annular cutters, and with concrete, they're called coring bits. But the principle is the same. What we do is we cut out the circumference of the hole rather than evacuate all the material, and what this will give us then is a core or a plug that we're actually cutting out. Again, this is way more efficient, and it requires much less power in the drill and much less effort then to manage that process. Now, before we move on to the operation of drill bits, I just want to spend a few moments on identification of them. Here on the desk I've laid out three different types: masonry here, wood bits here, and steel bits here. And what we'll do is we'll just look at each of them and tell you how to identify them. Now this masonry bit is the largest one I could find just for purpose of demonstration, and you'll see a commonality in all masonry bits is that they will have this little chevron shaped bit basically brazed into a steel shaft, and that chevron bit there is generally sort of a tungsten alloy or some type of hardened bit for percussive purposes, because as you're drilling the hole, this will be hammering in and out and breaking out the material, and then the flights of the drill will be used for dust removal. Now when you're measuring one of these, you measure across the width of that little tip at the top. Okay, so if we take our calipers here and we measure, okay, that's measuring in a 20.3 millimeters, so that's a 20 mil masonry bit. Now the same principle applies to the smaller versions, so we'll take these out here, take one of these out here. Now a bit dirtier for that authentic look, but if we can get that in focus there now, you'll see the same makeup there where you have the little chevron-y bit stuck inside in a sort of a narrower steel shaft. Okay, so that's masonry bits. Now when it comes to wood bits, there's a number of different sort of configurations of them. Your smaller diameter bits will be made up, and if we can get that in there, right, what we'll have there is a little sort of spiky bit sticking out, and that's called the brad or the spar. And what that does is it guides the drill bit through the hole, and then the cutting edges are beside that. There's two of them there, and as that spins, those cutting edges basically act like a high-speed chisel and scoop out wood fibers or sawdust out of the hole, and then again it's pulled back along the flights and it should evacuate the material for you. On the slightly larger wood bits, right, we've a slightly different makeup here, whereby the brad on this one has a little thread form on it for pulling it into the hole, and again the cutting edges are out here, and when you're measuring one of these, you measure from the tip of one cutting edge to the tip of the other cutting edge. Okay, Now, the third type of sort of solid drill bit is called a spade bit. And again, you'll see a very pronounced spar or brad here at the top, and then the cutting edges then are beside it. These are for sort of slightly larger diameter holes, and because wood is a soft material, we can get away with a much bigger bit, okay, rather than steel or masonry. Now, the third type of bit we're looking at here is a bit for drilling steel, and this one is from a lathe, so you would be putting this in a hand drill, but at the same time it'll demonstrate well the geometry of a steel bit. Effectively speaking, most general purpose steel bits have 118 degrees across the top here, and we'll say the smaller versions are sharpened to a point, so the full width of the drill bit will drill a hole. The very large drill bits then for bigger machines like bench drills and lathes and stuff won't have this bit here in the middle sharpened and will require a pilot hole. Now, before we move on from drill bits, I think over time what you'll find is that you'll have unidentified bits hanging around the place. There's a number of methods of measuring these, very difficult with a tape measure because of the rounded surface on the drill shank. So you have a number of options available to you. We'll take this one out here now, and when you're measuring a steel bit, just measure across the shank, and that's coming in at 7.86 millimeters, so that identifies that as an 8mm steel bit. Another method would be to pick up these, if you ever see them around cheap, they're called drill gauges, and all they are is a series of holes drilled in a piece of steel with the numbers marked next to it there. So we'll say when you're holding an unidentified drill bit, you just keep offering into the holes until you find the one that it fits snugly in, and this one here tells that it's an 8mm 8mm hole, so therefore an 8mm drill bit. Now, one thing to watch out for there is as you use drills and they get sort of a bit scarred from use, what you'll get is a few burrs or little rips in the steel here, and that'll widen that. So if you are trying to measure it, give it a rub of sandpaper or something like that just to smooth it down, so that you'll get an accurate measurement when you're going into holes like that. Okay. Now, first section is metal bits, or bits for drilling metal. I'm going to focus on drill bits specifically for drilling steel. This is the hardest metal we'll encounter normally, unless you have a leaning towards making a set of titanium or adamantium bookshells. There are specialist bits there for softer materials of steel like aluminium and copper, but for the homeowner, a general purpose steel bit will cover all of these. You'll drill aluminium away fine with a steel bit. Now, drill bits for steel come in many colours. Some of them are black, some of them are silver, some of them are goldy coloured. All they are is different alloys of high-speed steel or different coatings on them, just to try and make them that little bit harder. For example, this one here is a high-speed steel bit with a titanium nitride coating on it, and that's, you'll see it there written on a packet of drill bits, TIN. That's big T, small I, big N for titanium nitride. The black bits are hardened. Some of the silver bits are high-speed steel, which would come hardened already. Don't get too concerned about it. For a homeowner, a steel bit is a steel bit. Now, to start off drilling steel, right, we'll take our drill, our bit, we'll put our bit in the drill. We'll make sure that this is operating clockwise to tighten it first, and you'll feel the jaws bite on the drill bit. When they do bite on the drill bit, we then tighten further by hand until you can't get it any tighter. The drill bit, when you're using it, will be rotating clockwise. The cutting bits or the cutting faces on the end of the drill bit are the bit that do the work. The side of the drill doesn't do any work. All these flutes are for is for evacuating material out of the hole as you're drilling it. Now, when it comes to drilling holes with a slightly larger diameter in steel, when you break through to the far side of the hole, sometimes the drill bit will catch on the ragged edge of that and it will bind. So if you feel that you're starting to push through to the far side of the hole, what you can do is you can turn the drill speed up slightly or pull your trigger slightly in further, just to speed up the drill, and that the momentum will carry you through that ragged bit there. I'd also recommend, starting off with your first drill bits, is to take the handle, here we are, the handle that came with the drill, stick it on over the collar there where it belongs, and then tighten it down, so that as you're drilling the hole, you've a two-handed grip on the drill, because they can give a good kick as they break through the far side. Now, one last point to remember before we move on from the drill is make sure that your gearbox setting is set to the drill bit there, or whatever marking indicates there that you're not operating a clutch, and you're definitely not operating in hammer. Okay, so we'll put that aside for the moment. Now, when it comes to starting the hole, drill bits, especially steel, are inclined to wander as you start off, so we have a number of options available there. This here is a center punch, and what you do there is you place it where you want the hole, and then you give it a good tap of the hammer, and what that'll do then is it'll create a little dimple in the steel, and the dimple in the steel will accept the little tip there at the top of the drill bit, and that'll stop wandering for you. Now, there are other types of center punch as well. This one here is called an automatic center punch. Now, mind your ears, that's the way they work. And then if you're stuck without any type of a center punch or marking equipment, what you can do is use a large nail, give it a good thump of a hammer, whilst minding your fingers obviously, and all you want to do is create a little dimple, something that you can actually stick the very tip of the drill bit into to stop it wandering. So we'll put some of this stuff aside now. Now, if you're hand drilling, just be aware that drilling a straight hole exactly where you want it is quite difficult. Drill bits themselves can be slightly oversized or undersized, and we'll say as you drill, the drill bit will wobble into the hole, and it could widen the hole or make it slightly crooked. So if you're looking to match up one piece of material with another piece of material, maybe consider going up 0.5 millimeter or 1/16 of an inch oversize, to give yourself some flexibility as regards getting fasteners to match up. Now, when it comes to larger holes then, we have a number of options available to us. Generally speaking, handheld drills will accept 13 millimeter shank tools, and the shank is the base here. You can get some bits which are larger cutting sides than shanks, but generally speaking, drill chucks will accept 13 mil or 1/2 inch thereabouts. So what we look at then is we've a number of options available to us, as I said. Right, the first one is a step drill, and this drill, and if I hold it in there, you might be able to see the writing on each of the graduations on the step drill. It gives you a number there which indicates the diameter of the hole that you're cutting. These are useful for light sheets of material, car bodies, stuff like that. As regards heavier stuff, these are cutting on a number of different sections. If you're cutting, we'll say, an inch thick of material, this will be trying to cut on 1, 2, 3, 4, or a good number of these, and the torque required for that will be just phenomenal. So these do have their limitations as regards thickness of materials. The next one up then is a hole saw. Now, these hole saws come in sets, and what you'll find is there will be 20 mil, 25 mil, all the way up to whatever. Now, this particular one is mounted on what's called an arbor, and the arbor shank, it's a hex shape, and that will clamp into your drill. And then what you do is you mount, number one, a pilot bit in here, and if we can find one, you mount a pilot bit in there. There's a little set screw here which you tighten in obviously with a screwdriver, and then you mount your actual hole saw then outside. Now, a lot of the hole saws will come with little retainer clips or little retainer teeth there, which match up with the holes on the inside there. So you put them in like that, and that'll slot in, and then you tighten this up. So that'll give you some element of rigidity as regards drilling a hole. So the way this operates is that the pilot bit will stick out beyond the face of the hole saw. You drill your hole through, or part way through, enough to give you some element of guidance, and then at some point then the teeth here will engage with the material, and what it does is it cuts a plug out of it. It doesn't cut all the center out, it just cut a big disc out of the middle of it. Okay, now when it comes to heavier material then beyond what a hole saw will accept, we're looking at heading into the road of annular cutters and mag drills, they're called. And the way a mag drill operates is that it has a magnetic or switchable magnetic base on it which clamps the drill to the work. The bits then are mounted in the chuck of the mag drill, and they're different than your normal drill bits. You'll see two flat faces there at 90 degrees to each other, and there's two set screws on the chuck of the mag drill which tighten in against those and provide clamping force. These generally do not require a pilot hole, but they do come with a guidance pin, and the pin sits in the middle of the annular cutter, and the very tip of it then is used to orient yourself onto the dimple mark you made with either your manual punch or your automatic center punch. Now, one last thing, or one last piece of tooling, is a deburring or a chamfering bit. What this does then is it just tidies up the edges or the outsides of the hole so that there's no burrs or bits of chips attached to it, which you can obviously cut. Now, for masonry bits, we identified the masonry bits earlier by the chevron shaped insert at the top of the drill body. That's a commonality in all masonry drill bits. When it comes to mounting the drill, or mounting the bit in the drill, fairly straightforward. We stick our bit in, tighten up to basically just rotational tight, and then tighten properly. When we do masonry drilling, very important to have the hammer action enabled on the drill. If you don't have the hammer action enabled, you won't make any progress through the hole. So we start off with our hole, and I would suggest, if you're drilling a larger hole, to use a smaller bit first. Let's say for example, in this particular instance, we have a 5mm here. So use the small bit both to mark the hole on the wall, start to drill off very slowly with the hammer action, and what that'll do is it'll dimple the surface, and then as you progress you can exert a little bit more pressure and speed and push through the hole. This is particularly important with bigger drill bits drilling into concrete. Concrete is made up of aggregate, sand and cement, and what aggregate is crushed stone or gravel. And if you hit a piece of that aggregate when you're starting off the hole, it'll have a tendency to deflect the drill bit to the side, because the drill bit wants to follow the path of least resistance. So just be aware of that if you're trying to make a precise hole, or a hole in a precise location, to start off small and then make it bigger as you go along. Now, as you're drilling the hole, the very tip of the bit is doing the hammering action in and out, and then the flutes of the drill bit will be taking dust out the back of the hole, and you'll see that falling. An important note to remember is that the flights or the flutes of the drill will not take all the dust out of the hole. So if you want a 2-inch hole to put a 2-inch anchor into a wall, if you can't get the dust out, you're going to have to drill deeper to cater for both that 2-inch or 50mm anchor, plus the dust that's going to be remaining in the hole. Now, there's a number of ways around this. As you're drilling, you can minimize the dust by pulling the drill back in and out of the hole, and that'll pull some or a lot of the dust out. Second option then is with a range of, if you have access to an air compressor to blow the dust out of the hole. Mind your eyes though, because it blows back in your face very easily. You could use a vacuum cleaner and try and suck some of the dust out, or possibly even a garden hose and flush it out. That's okay in walls where the dust will fall out. If you're drilling into the floor or the ground, then your only options are drill deep to take the dust, or get the dust out of there with some method. Now, just as a a reference for the future, if you are doing a lot of concrete drilling, or you have a lot of concrete drilling jobs to do, the hand drill will only go so far as regards depth of hole and size of bit. You might look to upgrade then to the next step up in the equipment chain, so to speak, and look at what's called an SDS drill. Generally speaking, the SDS drills have a much more powerful motor. They have a different mechanism as well for creating the hammering action. In a hand drill, there's just two discs which bump off each other as they go around, whereas in the SDS systems, they have a piston mechanism which gives a much more aggressive percussive action, and much harder. Now, SDS, I'll just show you this box here now. These are SDS Plus bits. There's three types of SDS bits. There's SDS Standard and SDS Plus, which are both the same size and are interchangeable. And then there's SDS Max, which is much bigger. The shanks on them are 19 mils, somewhere around there, or 3/4 of an inch. They're a large bit, and the equipment for running those is much larger. But the SDS and the SDS Plus are reasonably small, and the way these operate is, I'll just show you the shank of that bit there, where you'll see the indentations on it, and what they do is they match up with the retention mechanism on the SDS drill. Very easy to mount. You just stick them in and slot them in like that, and they're secured. And then to get them out, you pull your collar back and pull out. Now, they're fairly expensive bits of equipment, so my suggestion is that if you have a number of large holes to drill, and you're looking to go down the SDS road, try your local tool hire shop. They rent the drills, they rent the bits, and they can give you a good idea as to what type of equipment you want for the particular job you have. Now, after we've sort of gone through the hand drill and the SDS size, and we go up the food chain then as regards larger diameter holes, we're into the hole saw approach again, and in a concrete context, that's called core drilling. One last item to mention is that when it comes to very hard surfaces like ceramic tiles or glass, there are specialist bits there for those, which I think are impregnated with diamond on the tips. Now, in our identification of drill bits, we looked at how to identify a wood bit, and we just mentioned that there was three different types. The first is a normal solid bit, and again, you identify these with the little spar brad sticking out. We outlined spade bits, which, because wood is a soft material, we can actually use quite large diameter spade bits. Now, bear in mind that they exert quite a bit of pull on the material, so make sure that you have your drill well secured in your hand. When we migrate then to larger size holes, what we're looking at then is what's called a hole saw. And this particular one, you can see that the teeth on it are there's quite a big gap in them. That's suitable for soft materials and wood, etc, etc. So the way a hole saw is made up of three sections as such. There's the hole saw itself, and they screw off the arbor, and they come in a range of sizes, 1 inch, 2 inch, 25 mil, 50 mil, whatever size hole you're looking to drill. The arbor itself then is secured into the drill with the shank. I'll just demonstrate that now. And when it's mounted in the drill, you'll notice that there's a pilot bit there, and the pilot bit is secured into the arbor with a little set screw or some type of fixing there. Now, the next bit now is the hole saw itself, and that's mounted on by screwing it on like that. And most arbors will have a retention mechanism, either a screw in or a spring loaded one. So this particular one is spring loaded, so we'll pull the springs back, and there's keys that come up through the face of the arbor there. Sorry, I'll just show you. And they mate with the some of the holes on the back of the hole saw itself. So we'll screw that on to there, and then we tighten in until our arbor fixing mechanism clicks in. And effectively then what we have is our pilot bit sticking out here, and then once we get into the hole some little bit, the main teeth of the hole saw then engage with the material and cut it out. Now, when I say wood and soft materials, by soft materials I mean there's a selection of particle boards out there. Some of them would be plywood, chipboard, OSB, MDF, and OSB stands for oriented strand board and MDF stands for medium density fiberboard. And they all have a commonality in them, that they're made up from wood particles or chips which are glued back together under heat and or pressure, and some of them can be incredibly strong depending on the manufacturing process. Now, it's also possible to drill nylon, some plastics, PVC, but basically the softer plastics. I would exercise a word of caution though with perspex. That can be very brittle and very inclined to crack. So if you are drilling a hole in perspex, do it quite slowly and maybe use a piece of tape over where you're drilling the hole, and that'll absorb some of the vibration or the shock and reduce the possibility of it cracking. Now, I'm just going to stick up two other pictures there. The first one is what's called a Forstner bit or a Forstner style bit. And what they're used for is drilling quite wide, flat bottom holes, and a lot of furniture makers and kitchen installers use those for mounting hinges and catches and things like that. The second picture up there is what's called a Countersink bit, and that mounts directly into the drill. And what that does is it widens out the opening of the hole and lets the head of a screw either sit flush with the material so it doesn't catch anything, or you can recess the head of the screw below the surface of the material, which will allow you to use wood filler then and disguise the hole. So that's wood bits. Now we're on to fastening and also unfastening, and the most common tool that we'll see for fastening and unfastening purposes is the little bit driver holder. And basically this is a hexagonal shape on both ends, both the male side here and the female side here, and the dimensions of that are fairly standard at 6.35 millimeters, which is a 1/4 inch. And you'll find that most bits and tooling for this style of bit driver are that same 6.35 mil or 1/4 inch. Just so you know, there's also handheld versions of this as well, which accept that tooling as well. So whatever bits that you can put in the drill with the bit driver holder, you can also put in a handheld unit as well, just to be aware of it. Now, to put that into the drill, generally speaking, drills have 3 jaws in the chuck, which means you can clamp onto round, you can clamp onto hexagonal stuff, which is 6-sided, or well, I've never tried 12, but you're not going to put anything square in there anyway, okay? So we stick that in, we tighten up our chuck on it, and then hand tighten. So we have our bit holder mounted in the drill. Now I would suggest that you move your clutching mechanism to on, and maybe stick it halfway at 6 or 7. That will give you some slippage so that you're not tearing the heads off screws or overstressing fasteners. So we have our bit driver in, and the way the bits go into the bit driver then, or they just slot in there. A lot of these are magnetic. There are other styles as well, and I'll just show you a different one over here. This one is a bit fancier, and when the bit goes into the bit driver holder, the collar pops down and locks it into place, and then to get it out is just a case of pull up the collar and out it pops. There are other ones as well. This one here is longer obviously, but it also is flexible as well, so it'll get you around a corner or into a tight spot if necessary. Now that we have our bits mounted in our bit holder, we'll go through the various heads that you can get and that you'll come across most often. I'll start off with a flat, so hopefully we can focus on that now. We don't come across too many screws like that anymore. Generally they were used for furniture and stuff like that. Those heads are inclined to slip on just a normal slot of screws, but you will find some here and there. Next one then is a Phillips head. Okay, and again we'll try and focus on that. And the Phillips head has a cross design to it, and a lot of confusion arises between Phillips screws and Phillips Bits, and also Posi Drive, which is the sort of the newer version of it. And I'll just find a Posi Drive bit now and just show you the difference. The Posi Drive bit there, you'll notice that between the four main veins of it, that there's four additional little veins. And in a Posi Drive screw, which we have here, and I'll try and hold this up so it focuses, you'll be able to see that there's four little smaller cuts into the screw head along with the four main ones. That's for increased register and sort of clamping power between the bit and the screw head. Now the Phillips bits were designed originally to be able to slip out when a particular force came upon them, but the Posi Drive bits are designed not to slip out. Now that doesn't mean that you won't slip, and these bits do slip, especially when you're putting in sort of larger ones. So these get damaged, but they can be replaced. And let's say, for example, you can buy little boxes of them there. So there's 15 available in that box there of Posi Drive 2. Now, just as an additional piece of information, if you're buying screws, buy them by the box. Don't buy them by the bag where they're unlabeled and you've no idea what they are. Here it tells you these are 5mm by 25mm long, and it takes a Z2, which is a Posi Drive 2 head. If they were Phillips, that would be PH or H2, and both Phillips and Posi Drive come in a range of numbers from 1, 2, 3, 4 and 5, I think, but the most common ones we'll come across will be Phillips 2 and 3 and Posi Drive 2 and 3. So make sure that will say you have a Posi Drive head to match your screws. Now, moving on then to the different types of bits that we'll come across. I have a set here, and the next ones will be basically what are called Allen keys in Ireland anyway, or in Europe, but they're also called hex heads. Now, one side of it there is the 6.35mm, which will fit into our normal bit driver holder. But the hex head then on the other side will be a different measurement. And just to give an example of different sizes, they're both 6.35mm at the bottom to fit into our tooling, and then they're different sizes at the tops for driving different types of fasteners. Okay, now that's hex heads. Then an additional type of driving head is what are called torques, and torques then are these fellows. Okay, so hopefully now that appears. They're similar enough to hex heads, but you can see that they're sort of a star design across the shape, the head of them there. Now there's a number of different torques. There's solid head ones like this, and I'll just show you a different torques one as well, whereby there's a hole in the middle of the head, and some of the torques fittings have a little dimple or a raised bit at the bottom that registers in there with that. Now on to our next set of tooling is these fellas here. Okay, and what these are hex to square converters or adapters, and what these will do is they'll turn the 6.35mm 1/4 inch driver, which we'll just mount into the drill for argument's sake, like that, and they'll also accept then sockets. So this is a 1/4 inch socket, and I have two others here. This is a 3/8 inch adapter, so it converts the 6.35mm to 3/8 into the back of the socket, and you can mount that directly in the drill if you want. And then the largest one then is 6.35mm to 1/2 inch square drive, and again you can mount sockets onto those or other equipment which takes square drive tooling. Okay, now one last piece of hex tooling is this little fella here, which is a hex to basically a little socket end itself, and what these are used for is driving what we call tech screws or fasteners. And these are designed for going through roof sheeting into wood, There's a big range of these, from roof sheeting into steel, wood into wood, all sorts of different ones. But what happens there is that they have a little hex shape on them, which mount into those, and then you can drive them into whatever, you know. Now, one last thing before we move on is if you're doing a lot of drill driving, there is a dedicated tool for that, which is an impact driver. And the impact driver is effectively like a small drill, but with instead of having a hammer action, what it has is a rotary impact action. So it hits the screws and it turns them like that. Okay, and what you'll find generally is that the head on them, they don't have a chuck. What they have is a direct mounted bit holder in here. So we'll say, again, we'll take one of our standard 6.35mm tooling, stick it in there, and they operate then on an impact basis, and that's why they're called an impact driver. Now, just be aware, they're quite powerful, and they do strip the heads off screws very easily. Okay. Now we're on to our last section here, which is other tooling for the drill. For example, this is a little wire brush with a round shank on it. I'll just stick up a few pictures of other tooling along the lines of sanding discs, which you can attach sanding sheets to, mixing paddles, and there's also a set of brushes there which I found on the internet, including which looks suspiciously like a toilet brush. And far be it from me to comment, but if you need a drill powered toilet brush, it's probably time to up your housekeeping game, or alternatively to make an appointment to see the doctor. So that's about it. Thanks for watching.